What's up, everybody? So, we got another meetup. We're doing it. And just like usual, I have my trusty instrument here so that I can intro our guest of honor today. And the guest of honor, I mean, y'all probably know him. If you don't, you can just Google him. He's that famous. He's got all kinds of good pieces of information out around MLOps, around you don't need a bigger boat. Maybe it was the MLOps without much ops piece that he wrote. And I'm just going to go ahead and sing a little bio intro for you before I bring him out. Jacopo, educated in several acronyms across the globe. Jacopo was the co-founder and CTO of Tooso, an AI company in San Francisco, acquired by Coveo in 2019. Jacopo is currently the director of A.I at Coveo, shipping models to hundreds of customers and millions of users. When not busy building products, he is exploring topics at the intersection of language, reasoning, and learning. His research and industry work is often featured in the general press and premier AI venues. I told you this guy was famous, yeah. In a previous life, he managed to get a PhD, do fancy things for a pro basketball team, and simulate a pre-Columbian civilization. Jacopo, welcome to the show, man. How you doing?
Thanks, man. I'm speechless about such an introduction. So I'm really so yes. For those of you,
Nobody
yes,
could
we were
see
joking
on cringe. You didn't have to hide your cringe.
No,
You could,
It was good.
my core for the MLOps community is always going to be who takes over for Demetrios when he gets picked up by a label. Like who's going to be the next leader of this community?
I don't think I can match this. So I'm gonna use this for my future talk and introduction. I'm just gonna remove my slides, my intro slides, and I'm just gonna have the you playing the snippet. And so instead of like yes, or and then said or Google me, or like and then below that or Google me. So if you want to do that, yes. No, like, it's like the Google thing. Yes, it was for people that were not here before. It was a joke, not because I'm actually famous, but because my combination of first name, last name in AI is unique. So if you do Jacopo Tagliabue, the only result, it kind of like kind of makes sense. So.
Yes, well, dude, I'm super excited to have you here. And I mean, when we had you on the podcast, I love talking to you, and now you're gonna give us some hands on the keyboard experience. I might actually learn something here, huh? So let's do it. I'll hand it over to you. As per usual, we've got the trusty friend, Ben, here, who's going to keep us honest and keep asking all kinds of good questions throughout this experience.
I had to force him to come on here just to teach us all how to write some good Python code.
Yeah, that's it.
Oh, okay.
All right. So when you're ready, Apo.
Let me. Yeah. So I'm sharing this. Can you see my screen? So I prepared literally like just like no more hopefully than literally like 4 minutes of intro for people that don't know what we do, which is not extremely important, but some of the things that we do explains why we do certain things in a certain way. And what we're gonna do today is hopefully a paradigmatic example of what people that have somehow our same constraints and opportunities, they can do as well. Okay. The general so there are two general housekeeping messages of today. So the first one is there's gonna be maybe some a lot of information. Maybe that's some information comes across, some information I don't know, maybe hard to digest immediately. But everything we say and do today is completely open source. So you have all the time in the world to go back, revisit the code, revisit the comments, revisit this video. The general message we want to send is a message of optimism. I don't know if you're familiar with the saying, like, what one fool can do, another one can. And I'm the fool. Like, so I'm the fool that, that kind of had to figure out a lot of stuff. And today I'm just trying to, shortcut your journey and kind of tell you what worked for us and what didn't. But if I can do it, if we can do it, you can as well. So this is a message. Even if you lose yourself at some point in some of the tools we're discussing, the general gist is, if I can do it, everybody can. The second message is not a message just about what we're going to discuss today. We're going to talk about tools, open source tools. We're going to talk about some vendors and so on and so forth. I'm not, people ask me all the time, I'm not affiliated in any way with any of this vendor. I don't get any money out of it. I'm one of the not many people in the community that is not trying to sell anything. I have nothing to sell. So what we do is purely for evangelization purposes, and the tools that we're going to mention today are tools that we know very well. May not necessarily mean that the tools that you may want to adopt is the tool that we know and like. Whenever possible, I'm going to point out to alternatives of other tools that we know and that we like for different reasons. I do believe that a rising tides lift all boats. So I do believe that the market is is big enough for a lot of vendors and a lot of different startups kind of positioning themselves slightly different for different trade-offs. So again, the general picture is we pick these tools and we're going to explain this tool. They're not the only one. They're here for a reason, but they're not the only one. And definitely, when possible, I'm going to point out to alternatives. On the other side, again, there's no hidden agenda here, and we are just super happy to to discuss this tool because they work for us. Okay. I'm gonna skip this introduction because because I got the musical one, so we're gonna immediately skip this thing about who I am. I think we already discussed that too much. So one thing that we want to do to set the stage is what we feel is kind of a small problem in our community of ML, right? I don't know if you're familiar with the concept of food porn. And so, you have here, like, a typical picture of like, a three-star Michelin restaurant. And then there was what I actually do, in my house. So this kind of view, when you want to glamorize, like some field and kind of make it all, shiny and fancy, when the reality of it, in many cases, it may be very different because people have different constraints. So what happened with food porn actually tends to happen with ML. So these are like some headlines, from a newsletter, which I actually like. But just to give you an example, so a lot of the things we discussed is like, what people at Uber did, or the super AI model at DeepMind, and then what people actually do tends to be way more similar to what you saw below. They import, like a linear model for sklearn, and then they just write 3 lines of Python to do that. This is not actually what I do because I do NLP, but you get the general gist. What is the problem? The problem with the field is that this narrative of big tech. We have 2 problems in misrepresentation that are gonna actually hinder your ability as a practitioner that is starting this to be effective. Misrepresentation number 1 is models are key to everything, and misrepresentation number 2 is that building ML pipelines is super complex. The picture you see here is like a random LinkedIn post, right? That it was in my feed a couple of days ago, and and your rightful complaint is like, well, how many people do I need to even start an ML practice, like a data engineer, a data scientist, a machine learning? Like, when does it stop? And what we want to discuss today with real code that works is that you don't really need all of this, or to quote myself, you don't really need a bigger boat. Like, very few people with the right tools can actually be terabyte scale pipeline that works effectively before you need to bring on more people or more complexity out of that. So the misrepresentation number one is false, because at the end of the day, for many people, the bigger gain in the data and in reliability and robustness way more than in model accuracy. So model accuracy tends to matter only at humongous scale, which is not the scale of most people. And of course, misrepresentation number two, we don't think that's true anymore. Maybe true 5 years ago, but now it's not true anymore that you need like 1 million people to write an ML pipeline that goes from data to prediction. And today we're actually, gonna run one that goes from raw data to prediction. I'm gonna see how easy that is. So the general guess is that you're not Google, but that's totally okay. There's a lot of cool things that you can do even if you're not Google. Last thing, I don't know if you're familiar with Ratatouille. One of the problems that I have getting old is that I keep making these pop references, but a lot of my audience actually is too young to get it. But the Disney movie, if you haven't seen it, and there's this famous line that says, anyone can cook. But there's a misleading, there's an ambiguous sentence. Anyone can cook doesn't mean literally that anybody can become a great chef. I can't, for example. But it means that once you get a great chef, that can come from anywhere. I think in ML is the same. Like anyone can do great ML. Like there are great ML people in many organizations. Unfortunately, since the barrier to entries are so high, it's very hard for people that are not a humongous organization to actually run cutting edge ML. The picture that you see here is not really a marketing, like this is not really a marketing point, but is if you think about papers in e-commerce, this is a 2020, but it's probably going to be accurate as well for last year. In e-commerce conferences, you see that most people that are actually pushing the field forward, which means also setting the agenda, which means also setting what's interesting, are humongous public companies: Amazon, Alibaba, Home Depot, Etsy, whatever. There's only one company here, like they publish a significant amount of contribution that is not, at this scale of company. And the point about this is not look how cool these people are, which happens to be us. The point of this is there's obviously something in the way we conceptualize how ML is built and how ML runs that makes the barrier to entry so high for people that have not infinite resources that the field really suffer from a problem of diversity and so on and so forth. So hopefully one side effect of today's walkthrough is to have and give people that have not infinite resources, but the tools, the means, to express themselves at the even at the highest possible level of innovation and R&D, and be able to do that, with reasonable resources. So we're gonna just skip this, and the only thing we're gonna talk today is this repo. It's called the Postmodern Data Stack. We're gonna watch it. Hopefully you did some homework. So if you're listening to this, you already went through this and set up some of the tools. If you're curious about more of this discussion that we're having about, the motivation about this and the philosophical implication, there's a mini series with my beloved colleague Ciro and Andrea. It's called MLOps Without Much Ops. It's 5 episodes on toward data science, which we thank for the opportunity to publish there. And it contains a lot of, real life hack of people building ML teams that are, small but very productive, and with a lot of open source code that kind of teaches you in a practical way how philosophy can be operationalized. I'm gonna pause a second before going into the code to see if anybody has any question about what we're doing so far, about what we're trying to do. All good? Ben, all good? Demetrius, all good?
Yeah, as questions come up, I will definitely pop in and pop out and share them with you.
Awesome. Yeah, because when I think when I'm full screen, I can see this window. So yeah, please interrupt me all the time. Cool. So as some of you may or may not know, like almost a year ago, to set the scene for today, we published this blog, this repo with a bunch of related material. It was called "You Don't Need a Bigger Boat," which again, very terrible pop reference for people that are young. But it's the idea that you don't need, again, humongous teams or resources to kind of do ML, at a reasonable scale. And if you go through the repo and you run it, you're gonna find out that you're gonna build something like this picture here. So it's something that goes from what happens in your data as your raw input data to feature construction, data validation, building a model, shipping a model, and tracking the model. And all of this is in the repo. And a lot of the feedback that we got from this repo is that, well, this is awesome, but it's kind of like pretty hard. It's like there's a lot of things to set up. There's a lot of moving pieces. So for people that are really new to this ML thing, this was useful as, okay, this is one way of doing this. But we got kind of the feedback that people wanted something that it was even more streamlined in the way to do that. So we kind of parked that, and we recently released it, I think last week, what we're gonna see today, which we call the postmodern stack. If you haven't gone through that, like, please, go on the GitHub now. Which is, as you see here, it's kind of contains the same general blocks that you need to build an ML model, but it's a much more streamlined experience. Okay, so there are less moving pieces. There's no orchestrator. It's kind of more focused on kind of give you this end-to-end feeling, but without all the bells and whistles of the other. Of course, you can turn this repo into the other one by adding again the stuff that is kind of being taken out. But the general point is we want people to be comfortable in moving from 0 to 80 and kind of make sure that they got right the basic foundational blocks of an ML pipeline. Okay. So before we dive into the data, I want really to the code. I really want you to go with me to the functional pieces of this pipeline. Okay. First, this pipeline is powered by real data. So if you go into the repo and you load the data into your Snowflake, that's real data. The data that we open source last year is the biggest open source e-commerce data set for session recommendation of all time. It's like 30 million events. So this is real data. It's not a toy data set. It's not toy meaning that it's actually real people shopping stuff, of course, entirely anonymized and so on. And it's not toy in the sense that it's like a quantity that is actually representative of a real world use cases. So we're not using the Iris dataset or the Titanic dataset here. We're using what people actually do. Okay. And the first thing that you do when you get your data in your data warehouse is to transform this data from a JSON payload, which we're going to see, to something that actually can be used downstream. Okay. So your friends here are going to be dbt, a SQL-based transformation tool, and of course Snowflake, which kind of support the entire computation that happens in the warehouse. Okay. Once you get your data in a good shape, then it's the second big block of an ML pipeline, which is training. Okay. In this case, we're going to train a pretty simple model. We're not going to talk at all about the model because it's not the point of today. It's going to be a simple LSTM for a sequential prediction. What we're trying to do here is answer the following question. Given like n product interaction that a shopper may have had in the past, what is the next likely thing is going to do? Okay, so if you imagine it as an input-output problem, the input is going to be 1, 2, 3, 4 products, which Jacopo have interacted with in the past, and the prediction is going to be the next likely product that Jacopo would want to see in the future. It's a standard session-based recommendation setting. I'm sure if you're not familiar from as a practitioner, I'm sure you're familiar from the point of view as a shopper. Like imagine you're shopping on Amazon and watching different type of TVs, and the question for Amazon is, can we predict which TV Jacopo is gonna shop next? Okay, and your friends here are gonna be S3 because we're gonna extensively use Metaflow capabilities of versioning here and storing, and then an experimental tracking platform, which is a SaaS product. In this case, is gonna be Comet. Okay, once the model is trained, then we basically need to deploy. Okay, so we need to make sure that the model that we train now is out in the world that can be used by somebody else, that is not in our laptop or in our cloud. Okay, to make sure that what we trained satisfy some qualitative constraints and quantitative constraints, we're going to run a suite of tests, which we're going to discuss later. It's called Recklist. It's an open source project that we pioneered at the beginning of this year. And then if everything is okay, we're going to deploy the model to its own endpoint. Okay. In this case, we're going to use Amazon SageMaker, which is just the inference part, which is like a PaaS service from Amazon. You're going to see it's very easy. You give Amazon the address of your model artifact, and Amazon is going to spin it up. Okay. All of this, if you see here, is going to be somehow orchestrated by Metaflow, which acts as a backbone of this entire pipeline. Okay. Any questions so far of what we're trying to achieve? Okay, I'll continue if nobody complains. So you should be able to see the table in Snowflake, and it's the same table that you're gonna get once you run the prerequisite in the repo. So if you haven't done already, there's a bunch of things you need to do to make sure that you can run this with me. Again, this is a real repo, meaning that once you complete this setup, you're basically, you're basically 90% ready to do production. So at the end of it, so it pays off to kind of be able to have, these accounts and these tools. But of course, if you want to just follow me while I talk through now and then do later the setup, you're super happy. You're super welcome to do that as well. So these are our setup to do. So what happens is that once you set up your Snowflake account, there's going to be one script in the code. We're going to watch it now. Let's use GitHub. I can share results too, but let's watch GitHub for now. Oh, sorry. Where is the... So you're gonna see here, it's called upload to Snowflake. Once you run this in your Snowflake, you're gonna end up with a table, which is exactly like the one you're seeing here, okay? This is mimic a typical pattern in data warehouse when you treat a data warehouse as a long series of append of events that happen in your company. In this case, we're simulating a recommendation engine. So what we're simulating here is basically receiving the data from whatever data collection mechanism, okay? And what does this data look like? This data is, of course, is a timestamp and a date, but what does it do? If you see here, this is an event that has been dumped into our warehouse, okay? So yes, some URL, all of this is anonymized, of course. Yes, some SKU. SKU means a product ID in terms of like recommendation. And then he has a session ID, okay? So this is the table you're gonna end up with when you load the data set into this. And this is our input, this is our starting point. We're simulating that we have this data in our data warehouse that we collected to some collection process. And our goal is to go from this, from this basically list of JSON to an endpoint in the cloud that is gonna predict, given a set of products, what I'm gonna watch next, okay? So the first part of the repo, which we're gonna see now. Sorry, one second. So if you open the my dbtflow.py file, this is the file that is kind of basically self-contained version. There's some modules here and there, but most of the logic of the entire pipeline is contained here. If you look at this, you're gonna see that even with comments, this is more verbose than it needs to be because it's educational. But if you see here, you're gonna find out that it was like 500 lines of code or something like that. You're gonna build an entire pipeline that goes from raw data, the one that we saw, to the actual endpoint that we do. Okay. So we're now gonna watch step by step on this pipeline. We're gonna discuss which of the step is doing, and then we're gonna run it together to see what is the experience when you run it. Okay. So at first, which is the first thing that we do, okay. So we're gonna just start our Metaflow pipeline. The start step of Metaflow, or in general in pipeline, is a good chance for us to what is called fail fast. Okay? So there's a good chance, if you see here, there's a bunch of assert, okay, and a bunch of checking, with variables and printing out debugging stuff and so on and so forth. So what happens is that when you run this, and for whatever reason, let's say you didn't put your API key for comment, or you fail to connect to Snowflake because your setup is wrong, your pipeline is going to fail immediately, okay? Which tends to be a good property for pipelines in our experience, because you don't want to go through, through a lot of steps of training and a lot of compute to just find out that you forgot to, put an environment variable or something like that, okay? So there's nothing special here, just a bunch of checks that just make sure that it is, okay? The second thing that we're going to do, okay, which is, run transformation. You see here, this is the typical Metaflow syntax. So we're gonna go from the step thing to the step is called run transformation. Okay, you see here, the step is run transformation. Okay, and what's gonna happen here is, depending on your setup, but it doesn't really matter, we're gonna run dbt to go remember from the raw data to the transformed data that we can actually work on. Okay, what does it mean? When you, I hope you can see my screen. So, oh, sorry. So I'm using dbt cloud here, but you can totally use the local version that's in the analytics, sorry, in the repo as well. So what happens is that you're gonna find out, if it loads, you're gonna find out that you can transform the data in your data warehouse with a bunch of SQL queries, and we're gonna prepare this data to be ready to be sent to our LSTM, our deep learning model for prediction. Okay, and we're gonna do it in SQL in a way that is like, you know, very easy to understand. Hopefully, SQL is a very easy language for most folks, and it's kind of replayable and version. Okay, so we know now that all the data preparation of this, or most of the data preparation, actually happens at these steps. Okay, if you look at this, and then we're gonna see what happens in the data warehouse. So there are two SQL queries. The first one, which is this one, okay, it's just a query that you see here that is reading from the raw data in the data warehouse. Remember, this is the table. So it's going to read from the data warehouse, and it's going to produce a standardized, let's say, exploded version of these events, like say a more flattened version. We're going to get a preview of what that's going to look like if you look at this. So when you go into Snowflake, you see this. Okay, this table here contains the exact same information of our raw table event, but as you see here is a much more friendlier tabular format, right? You see here that every row here represents a single event. You see that the SKU, that is the product ID, is represented as its own column, and so on and so forth. So what we're doing with this SQL query is just morphing from a JSON kind of dense representation, kind of like hard to read, to a more tabular and straightforward, version for people to run queries on it or run models. dbt, in this case, we're using dbt for an ML use cases, but dbt can also be used or should be used for, your visualization or your data analytics and so on and so forth. Okay, and then there's a second query, and the second query you can see also here represented as a DAG here, so one next to the other. The second query that we run, what does it do? It takes the table version and it prepares it in such a way that can be easily digested by a model. Remember, our model is a sequence-based thing. So what is the most common, what is a useful thing that we can do in SQL? Well, we can take the entire product that some user has seen, okay, and we can put it in a list, right? Because that's going to be our input and output for our model, okay? So the input is going to be the first element of the list as the input, and the output is going to be, the golden standard for the model is going to be learn to predict how the list is actually finishing, okay? Again, if you want to look how that will work out, this is what it looks like when you run this, okay? You see this, it's again a much simplified table compared to the one that you saw, and it just contains the bare minimum information that you need to actually run the code. So the most important field, of course, is this one, is interaction, which, as we said, is a list of SKU. This is a list of product ID. This is basically literally, together with the date to do the split, this is literally just what we need to then train our model, okay? So what happens, to go back to the main flow, is when you run this step, run transformation, what this code is gonna do is gonna run this project in dbt cloud. We're gonna see it running, okay? And it's gonna produce the table that we need for our downstream model, okay? So now we accomplished the first part of the pipeline. We went from our raw data, terabytes of raw data, millions of rows, to data that is already ready to be sent to a model to train, okay? Next up, what we're gonna do in the get dataset function, you see here again the Metaflow thing. So we're gonna go to dataset. We're gonna use SQL to query the final table. You see here querying nap session event, which is the table that we prepared. Remember, the table with all the feature. And we're gonna prepare the data set in a way that everything else downstream is gonna be able to read. In this case, it's called session dataset. It's an abstraction of recklist. The exact importance of this is kind of like not super important. But one thing that I want you to notice is this option here. So for those of you, or like same here, line 264. For those of you not familiar with Metaflow, Metaflow automatically and out of the box snapshot and version everything that you prefix with a self statement in your class, okay? So what we're doing here is very powerful. One, we're connecting to our data warehouse, and we're kind of like, offloading to that computing power the problem of creating basically our data set, okay? The second thing we're doing is that once we get back the results, we're basically automatically version this in the cloud thanks to Metaflow underlying thing. So when later on we're gonna train a model and then we need to debug it for whatever reason, when somebody asks you the question, well, where did this data set come from? Or like, what was exactly the data set that was fed into the model? This line here are gonna be your friend. Because without you doing anything, everything that has been snapshot here is gonna be stored in your cloud forever, okay? So you will always be able to go back to whatever training set you had or whatever variable you want to store and understand how it goes. After we complete that, okay, it's time for some GPUs, it's time for some training, okay? And you see here, so the next step in our pipeline is train the model, okay? And train the model is accomplished with this function, and there's a bunch of things we want to highlight here. First, this function has an enable decorator, okay? This decorator, what it does is a meta decorator. So it takes as input a decorator. You see here the batch decorator from Metaflow, okay? And depending on what you set as an environmental variable, it will enable it or disable it. This is useful for you if you want to try it out, this pipeline without batch, without a remote GPU. So you can just disable it. Or if you want to, to train the full thing with GPUs, you can just enable it, okay? But the idea here is that when you train on a GPU, by simply specifying this on top of your function, what Metaflow is gonna do is gonna automatically send this code and just this code, the one in this, trained model, okay? It's just gonna send it to the cloud, AWS patch. It's gonna run it there. It's gonna, store whatever result you tell him to store, and then it's gonna get back to you locally, okay? This is one of the most powerful features of Metaflow in our experience, okay? You develop locally, and then when you need it, you can spin off specific steps of this compute and just those to a GPU in the cloud to somehow run that for you, okay? And you can, if you want, this is another decorator. You see the pip decorator here. What it does is that at runtime, it's gonna make sure that the AWS pet job that runs the cloud has some of the dependency that you need, okay? If it's interesting, I can dive deep into, best way to manage dependencies with this. But just so you know now, it should be fairly straightforward. So what we're gonna say is, we train the model in the cloud with these libraries, okay? And this is like a standard, LSTM model with some standard, experimental tracking, and so this code shouldn't be that much.
A quick question, Jacopo.
Sure.
We have a question from somebody a little bit up, I think 2 steps prior. There was some inline SQL to access the data, and there was a question at why that was here as opposed to within DBT.
That's a good point. So so DBT creates, and this SQL here is only retrieving the data, right? It's not creating anything in our warehouse, and it's not a reusable function, meaning it's not something like the models that we just create in DBT that can be reused by other people. So we still need to access the feature in some way. So there's still going to be a SQL somewhere. But the key point of this is that this SQL almost contains no real computation at this point. It's just a filter, if you see here, because all the the major like data transformation happens here with our DBT thing. So very good question. So what we do with DBT is going from transformation to feature table or semi-feature table, and what is left have to do in the pipeline is retrieve those features and maybe, like in this case, filter for some properties that we find desirable, like the start date or the end date.
Just to be clear on that, though, just to understand fully, if you wanted to, for example, turn this into a macro and then just have the templated variables be passed into DBT, would that, in your mind, also be a reasonable way to do it?
Absolutely. Yeah. Sorry. Absolutely. If you prefer to, absolutely. Yes, absolutely. You can move some of these filters and parameters into DBT if you prefer that, and pass that as your SQL. Absolutely. If that's okay. Totally fine. Yeah. Absolutely.
Awesome. Thanks.
Absolutely. Thanks. Very good question. So going to so we train the model, and like at the end of the day, what you're gonna get is a serialized version of this. Again, you should be familiar with this by now. You see this self here? What does it do? The self thing here make sure that everything related to this model, okay, in this case, is being serialized in this kind of like object like JSON format, okay, is stored forever in our cloud, okay? And we don't have to do any additional stuff. We just do self dot something, and Metaflow is gonna actually do it for us. And we're gonna see it in the cloud later on, okay? So this is the same pattern that you see all and over again in this repo, is that leveraging built-in Metaflow primitives to somehow subsume a lot of work that we need other tools or we need other stuff to do that. And instead, we just do with Metaflow. We use AWS. Everything is kind of like just works out of the box. The test part, again, just make sure that things work well before we want to deploy. So there's a test step. The test step is exactly as you saw before. There's one new decorator here. Is the card decorator. Is a decorator that I'm very attached to for sentimental reason, because it's been co-developed by Coveo and our friends at Outer Bounds. What cards do is allows you to record like a visual representation of the information of this step that you can retrieve later as basically an HTML page, and you can share it with people in your organization. This is useful because it kind of like help developers self-document their step, and it produces automatically documentation that has been versioned and snapshot as well. Okay, we can go like over this later if there's interest. But what is going to happen here is that we're going to use our libraries called Recklist to make sure that what we do, so the prediction that the models make. So here we're going to use the model to make the predictions, and the prediction that the model may satisfy just by these two lines, satisfy some constraint that we deem important. Okay, and if everything is fine on that front, what we're going to do is going to go into deployment mode. Okay, so if we're happy with the test, we're going to go into the deployment mode. In this case, the deployment model is a very simple choice. Is SageMaker. So if you want to deploy the model, what's going to happen is you're just going to dump it in a format that doesn't make that makes it make it happy. There's a very specific format, and to do that, you're gonna store the model using this code here. So you're gonna store the model in S3, and again, you see here this is a specific S3 client that comes with Metaflow, which is A, very fast, and B, it allows you to version all the artifacts automatically. And then finally, which in what I think is a pretty well made interface from the point of view of AWS, you're gonna launch your model, you're gonna point to whatever S3 path you store it, you're gonna do some parameters of like which image you want and so on and so forth, and then you're gonna deploy it. So in basically 2 commands of Python, you're gonna have an endpoint in the cloud that is actually serving the model that you just trained. The rest of the function is just gonna check that the model is actually up and running, and then it's gonna destroy it automatically because we don't want to spend to waste computing. Of course, if you're gonna do this for real time, you're not gonna destroy it after you publish it, and you're gonna keep it up. But in this case, you're gonna see the model going up and down, and kind of works. And then finally, the end step, which again is like the start step, like is a standard step for Metaflow. In this case, there's nothing to tear down, but the end step is a good place if you have some some cleanup operation that you want to do, or you want to send some message to like I don't know, to an email, or you want to connect to Slack or something like that. It may be a good place for that to be. In this case, we just we're just at the end of the flow, so we don't have much to do anyway. Okay.
Hey,
any question before we run the code?
Sure. I have a quick question there.
Sure.
Let's say you in various different steps, you were creating artifacts that were actually running in some remote environment like AWS, for example, and you wanted to make sure you cleaned up whether or not the pipeline failed halfway through. Can you ensure somehow that the end step always runs no matter what?
Not that I'm aware of. What happens though is that each version and each artifact and each run is going to be separate. So if you run a new version and something happens, you say, like there's some errors or whatever, the artifacts up until that point are going to be saved under an ID. But when you rerun it, okay, you're going to create an entirely new ID with an entire new versioning. So there's never a case, it's kind of a stateless in that sense. There's never a case when, that when the artifacts kind of like collide with each other because the previous run didn't go through. Okay. So every run is a universe in itself in that sense, if that makes sense.
Got it. But for example, if you spun up your model and you deployed it, and then your next step was to do something with it, but that step crashed, and then you didn't have the end step to tear it down, you would potentially have to make sure that you tore it down by yourself by adding like a try finally block or something like that.
Absolutely. In that case of the model, let's say you have a prediction model, you have another step and then somehow failed and you want to kind of roll back the model, then you will need to make sure that in the end step, you somehow tear down, you do the delete thing that is here, right? You would do, the delete part here in your example would be a case of would be a try and catch in the next step. Let's say if something goes wrong in the end step, we want to delete the model for whatever reason, you would have to put it there. Yes, absolutely.
Got it. Cool. Thanks.
Yeah. The model is not, so this part here is handled by AWS, but it can be Seldon, it can be Bento ML. Like this part here has nothing to do with Metaflow per se or the model. This would be whatever provider or whatever service you want to use for serving. Okay. So the problem of making sure to tear it down if something goes wrong is kind of orthogonal to the choices that you made in how you orchestrate the pipeline. Okay. Totally. While the artifacts are like, for example, this thing here. Sorry. So what we say here. So this part here is actually a Metaflow thing. So the fact that this is going to be version and snapshot, this is part of the design choice that we made, and it's kind of like an essential problem and piece to have. And what's going to happen again is that if you run it twice, you're going to have two models. Okay, so there's never really a problem of doing that. If you look at this, so you see my S3, like you see my S3. So this is like where Metaflow stores this, and you see that there's like a lot of numbers here, and each of these number is a folder that corresponds to that run. Okay. So now what we're going to run like the flow, we're going to get a new ID, which we're going to create automatically a new folder. And this folder is going to contain all the artifacts about that ID. So to avoid, any overwriting or, stepping on each other's toe to run. Okay.
That's awesome. Very cool.
So what we're going to do now is run basically all of that. If you see the structure of this project, and it's very simple. So the idea is that it doesn't need to be complex. It needs to be as simple as possible for you to get started, but it's powerful enough for you to run, like a recommenders, a deep learning model on millions of data. Okay. So the good thing, hopefully, about this template is that it's simple to start, but it's kind of future proof, meaning that it's going to be months and months or years before you actually need to make significant changes to this. Of course, again, you can swap in and out, your different tools if you have different preferences on experimental tracking or warehouse, like maybe use BigQuery or maybe use Neptune, whatever. But like the general gist of this, again, is not telling you which tool to use, but I kind of give you a mental framework and a template of how to organize your code and resources. So when you run it, I can show you the environmental variable because there are some secret there, but make sure that that all your M file contains all the right parameters. And then when you run it, okay, you just run it as any other basically Metaflow stuff, which basically means if you want to specify a bunch of environmental variable like you see here, it's fine. If you don't, you can just run, because they're default. I have many profiles, so I need to do that. You just run Python mydbtflow.py, run. And when you run it, what's going to happen is that Metaflow is going to read this class that we discussed, okay, and that is going to go one step, after the other. And while it goes through that, it's going to create all the resources necessarily to, as we said, debug or snapshot and stuff like that. Okay. You see here that you see 2996. This is a new run. If you remember you probably see this. If you remember my folder, okay, so this is where the 2996 comes in, okay, is a way for Metaflow to create, a new version of the flow and make sure that everything that happens in this flow, okay, is going to be there. Okay, the first task has been done. You see here where task number 2 is run transformation. Okay, we're running with dbt cloud. Again, the code does give you the option of doing local remotely. We're using dbt cloud to show you one more tool. And what's happening now is we're using dbt cloud native API to communicate with dbt cloud and understand, how the workflow is actually going. Now we're pinging the API to see if the job is done. If you go into the dbt cloud, so you see here, this is my dbt cloud dashboard. If you see here, you're gonna see now I'm refreshing, you're gonna see that once dbt cloud loads, we're gonna see, you see here, there's a new job, success. This is the job. See that we have the ID here. dbt flow 2996. So this is the job that we just run, and this is the record in dbt cloud that tells us that the job has run successfully. In fact, if I go in my warehouse, everything's gonna look fine. So I'm gonna have, my data is gonna be there and it's gonna be ready for the next part of the code. Okay. So now we're starting the, we prepared the, you see here, this is the SQL query that we've been asked before. So we execute the query. We make sure that, that the number checks out. We're just working on a small part of the data set to make it faster. And now we start the training part. So this is just, standard, I'm sure you're familiar with it, standard Kera stuff. We got like, see here, comment info. In fact, if I go into my comment dashboard, so this is the dashboard that collects all of our experiment in this particular type of model. So this project is called LSTM Rex. We're gonna load it again, and you see here there's a new one on the left. Okay, and this is the dashboard that has been, this is the data that we've been sending now from the code. Okay, and then when when it's done, you can compare it with with all the others. With all the other runs that we did before. And of course, it's a collaborative instrument, so everybody in the team can kind of like, chip in and kind of see what everybody else is doing, okay? So this is training just, again, it's training just a random like set of epoch on this data set just to show you how it goes. And we're gonna wait like a minute until it finishes and it goes to the next step. Is there any question on the other tools so far that we've been encountering? Okay, so see, this is done. Now it's gonna upload the final parameters to the platform, and now we're gonna do the testing using Recklist, which again is our library for testing, and it's gonna print out some metrics for us that are important. But any question while the computer runs? Okay, I guess no question. So let's wait until it starts the next task. Okay. You see the test results here is just an output of like a console output of Recklist, meaning that the system is actually running the code. In this case, it's printing a metric called iterate at 10. It's a standard metric for a recommender system. Again, that's a talk for another time. But it basically means that it's working. So what happens is a final step. You see the deploy model step now. We're starting the task. And so what happens is that we're going to take the model that we train in the snapshot history, and we're going to tell our friends in AWS and SageMaker to spin up an endpoint containing that model. Okay.
If one part of this fails, does Metaflow have any particular debugging tools or UI tools for helping you understand your pipeline and what went wrong?
Absolutely. So one thing before the question is, like, if you see here, this is my SageMaker, you see that this endpoint is being created, right? So this is working. You see this is the name of the endpoint, it's being created and so on. So just to show you the entire thing working end to end. And then of course, after the creation is going to be teared down because of what we discussed, just not waste computing. But of course, in your case, you can do that. For Metaflow, so when things fail, there's many things you can do. You can use the Metaflow API client to just access the entire artifacts. Like a very cool thing about versioning everything is that you could know the state of any variable or any dataset at any point in time during any run. Okay, and you can open a node. There's a standard API that you can use. It's a Python package from that, and you can retrieve anything that you send to the cloud. You can retrieve exactly this. So that's typically your go-to. So when something goes horribly wrong and you can interpret that from the console, what you do is that you kind of go back to the artifacts that you produce and you try to understand why they don't work. And then second, there's a Metaflow UI now. So if you want, there's a UI you can actually spin up, which allows you to kind of see better, logs and what fails, what doesn't, and it's kind of very useful when you start having, instead of one flow, you have like you start having dozens of flow. It's very useful, but we haven't adopted that yet. Okay, so I don't have a first-hand experience in that. Okay, but I know that there's also this possibility for people that want to do that. I think it's been released like 2 or 3 months ago, so it's a very new thing.
Very cool.
So SageMaker is going to do its thing. SageMaker is not super fast, as you probably know. So at some point, this endpoint creation is going to be stopped. It's gonna be done. It's gonna work, and then it's gonna be destroyed. But I just wanted to show you the end-to-end version of how that works. What is cool about this setup is that it's really future-proofing, meaning that so there are two main computation here that happen. Well, if you want, three main computation that happens, right? One is transforming data and aggregating data. But since we're using DBT or plus Snowflake, the fact that we have 4 million rows or 40 million rows doesn't really matter. Snowflake can totally handle that transparently for us. Meaning our SQL query is gonna stay the same even if our data grows 10x. Okay, first, our build will not stay the same, but our coding experience will be exactly the same. Then there's the second part of compute, which is this one, which is training. Okay, and today we train locally just because we want this to be a bit faster. But if you go from 4 million rows to 40 million rows, you just enables this decorator. So it's going to be one change in your environmental variable. And now you have the full power of the cloud to train this. Okay, again, no change to the code. The exact model, everything else was going to stay constant. And the only thing is that you're going to change a parameter. And this is going to work at 4 million, 40 million, 400 million, whatever you want. Okay. And finally, which is serving, is similar. Like now we're using a pass service as SageMaker. And if you can change dynamically, again, one line of code, you can change here the serving image and the SageMaker instance to make sure that, if you make changes in the sense of the scale of the model, of the type of model you're serving, it's one line of code to make that possible, okay? So you start with 200,000 rows or whatever, and you go to 30 million, and you don't have to change a single thing in all of this, in not some parameters, which I think is the real lessons about this template.
Speaking of that SQL that you were just talking about, how it scales, there was another really good question about the transformations that you actually made on the SQL and how to maintain consistency or guarantee that consistency when you're going from, you're training perfect stale data or perfect batch data into your production data where you're kind of getting live data.
So there's a very good question. So data quality is a problem, which of course is orthogonal to this setup. Like you're gonna have it anyway. So there's a bunch of things you can do, even in DBT which we haven't shown here. But for example, there's a suite which is called, I think, DBT expectation, which kind of allows you to do this sort of great expectation quality check on your DBT transformation. And so what you're gonna do is not you're just gonna run DBT, but before doing anything else, you're gonna check for the quality of that using, for example, DBT test. So that's definitely one good option. If you go back into the original BiggetBot repo, this problem has been taken care of by a single step in Great Expectation, whose entire kind of function is to make sure that we maintain quality and consistency before even kicking off expensive training job. So this is a very good question, but let's say for the postmodern stack, we kind of postpone this problem, to give you the end-to-end, to give you one less thing to worry about in the first pass, because at least in this case, our data is already been, our data is already well connected. But once you go and move to the next step, I would totally suggest to have one data quality step, call it however you want, which can either be done through DBT or plugin of DBT in the warehouse, or through Python. If you're more familiar with Python, you can do it in Python with Great Expectation or whatever tool you want to use.
Cool. I'll share a link to your bigger boat repo as well.
Oh, sure. Okay. Thanks so much. That would be great. Yeah. SageMaker still thinking about it. But it's gonna come. I promise you, it's gonna come. But yeah, nothing specifically on this hinges on SageMaker as your deployment thing. The general gist is, as long as you can ship your model artifact somewhere, this concept is still gonna hold for all your use cases. Any more question? Tooling, things that are unclear, things that you try and run and it's not working. Oh, okay. So SageMaker run, it creates the endpoint. This is a result of the run. So it's when you try in the code and predict it. So there's a line here that is gonna check if the endpoint is actually up and running, and the answer is yes. So it's gonna assert, and now it's gonna delete the endpoint. and it's gonna end this. So this ends the entire pipeline from data to an endpoint that actually serving prediction. If you go into the Metaflow folder, you're gonna find that here you see every step as a name, okay, and then you can get all the things that you want. So for example, if you want to go here, you're gonna get the things that you need on that sense. Okay, so everything is stored for you in a way that that it actually makes sense. Okay, and you can retrieve this programmatically through the Python API that is provided with Metaflow in case something goes wrong or you want to inspect whatever was going on. Okay. Any question, clarification, things you like, things you don't like, anything you want to modify or like ask what this would look like if we do X instead of Y. Like I'm super happy to literally ask me anything.
Sure, I can ask some questions about the particular tools you picked, because a lot of them are very popular and standard tools in the stack, but it didn't seem like Metaflow really at all cared about which tools you were using. Are there any particular integrations that Metaflow builds for specific products? Like, for example, thinking about in Airflow, you have certain operators that certain companies build that make it easier to concatenate or to combine them together. Is Metaflow completely agnostic to the tool, or do they have operators to let you do things easier?
So in my experience, there's a lot of community effort into so Metaflow, as you see, is a very easy declarative way of building your pipeline infrastructure. So there's effort in improving this connection with the underlying infrastructure, because that's, I think, where most of the value of Metaflow is in this local to cloud deployment with no change in code, right? And so you have the batch decorator for AWS batch, you have the Lambda decorator for Lambdas, you have the Kubernetes one for generic Kubernetes. So I think there's a lot of effort into making Metaflow as a concept compatible with different runtimes and different computation. Because the general lesson is you run your code, which is somehow decoupled from the question where does the code run and under which conditions, and so which is what I think is cool. Like you focus on the code and you can ship it whatever you want. But if you want to run, like if you want to build like a integration for, I don't know, like experiment tracking and so on, I mean, Metaflow is fully open source, and so it's very easy to write your custom decorator. Some of the decorators that you see in our code, like the pip decorator, the enable decorator, are actually custom stuff that we just use ourselves, and they are like available for everybody to use.
Sure, I think that makes sense. I was also thinking about that self annotation that you can use in Metaflow to actually serialize and store everything. Yeah. I'm curious how that, and I guess in the combination, the other question I asked would work if you were using, for example, Spark. So how could you use Spark in Metaflow? Like, where would you connect to the cluster? If you did a self.df and it was a Spark data frame, like certainly that wouldn't serialize to, or maybe they would serialize it. Like, how would that work in that kind of environment?
I haven't seen Metaflow used with this type of like like long running, more old school type of like computing environment. I think the cool thing about like we used like the company that we built and then we sold to Coveo was built on Spark and Airflow, like was built on kind of this first generation of like this entire tool. So the question when we set up to build all this evangelization and tool is like, what would we need to do to rebuild our own company, but today? And the truth of the matter is that the scale we are in, which is reasonable scale, but not humongous, there's mostly no need for a tool like Spark, as most of what Spark was doing, Spark SQL, is being subsumed by Snowflake, which is a much better abstraction in basically any possible way. And once that data is abstracted and the aggregation are coming in, my modern laptop, or thanks to Metaflow, any box in the cloud is big enough for you to train a model with hundreds of millions of rows, which satisfy 99.9% of practitioners outside of 4 companies, which would rather do something else. So I think the sweet spot for the Metaflow of the world is people that may have very sophisticated models, like somehow we do, or even do research. That we even write papers with Metaflow, okay? But we don't have the humongous, like we don't have a petabyte of data to move around. So at the end of the day, the things that we serialize and deserialize are always in the, in the gigabytes or terabytes thing. Second point about the self thing, which is a flaw of the current, like a flaw, like which is something that the problem needs to be improved upon, is that you can always self dot something if you can pickle it. That's why there's not, when you see the self model, we didn't really serialize the model as the Keras model. You have to decompose it in this JSON of weights and stuff, because in that moment that it become pickable, because you cannot pickle, of course, like a model. So there's some room to improve, honestly, that interface for ML people, especially for standard stuff like PyTorch or Keras models and so on.
Yeah, I assume so. That's sort of what sparked the question when I saw you created that like JSON representation of the model. But I guess that in a lot of ways that does make sense. Like, you probably don't want to be able to serialize. You probably don't want to be able to save anything in the world. There probably should be some limits to what it is that you can save. And pickle seems reasonably as good of an option as any. That's very cool.
I mean, absolutely. But my only point is that since it's target to ML practitioner, I think like a shortcut to serialize, again, the most famous frameworks would just be useful. Like that. Of course, again, you can work around this like we do, but like we're not saying we need to self-dot everything. But honestly, models are pretty important in this ML thing. So I think that I think a better support will I think will come in the future to do that. And so it's even gonna be even simpler than what it actually is.
Yeah, and some models already do. I think that you can pickle any spacey model, if I remember correctly. And for example, something I was thinking about within your demo is like using MLflow models to represent not just the model, but the model runtime with the Python environment and all the kind of metadata you need to actually get it running. Yeah, it's very, very interesting. I can see a lot of ways. For example, if you're not using S3, but you are using MLflow and you want to package up and deploy your models, even on Kubernetes, it wouldn't really change anything. It wouldn't matter.
You can, instead, if you on top of Metaflow, you want to store and serialize artifact in something that is that is maybe a model registry, or like there is less bare bone than your S3. It's all like this. You're just gonna add one line of code to do that. You can totally do that with common net. Like even inside your experiment tracking, what we're showing here is the bare bone. If you want to do more, you're super happy to do more. One suggestion that I have for people using Metaflow is, even if you have a separate environment for models and you may deploy to Kubernetes from there, fine, but still try to snapshot the variables in your code, because that's going to be helpful for lineage debugging and kind of like storing this timeless snapshot of what happened, which is very, very useful when you start running this flow like 10 times a day.
Yeah, I was thinking about, just because of how agnostic the whole system is, you could write your own decorators, like a timing decorator that stored an artifact snapshot of how long each step took to run. Or you just wrap your step and time it, and it says self.runtime or self.execution time and the name of the function. It's quite easy. It's very nice.
That's already built in. So if you use the Python API, all the steps already contained when it was started, which states it in.
Cool.
And so yeah, but that's already a lot of stuff that we couldn't discuss. But like there's the cards. If you go to the README, it shows you how to display the card that actually show you the steps. So there's a bunch of things that are like like hidden gems in the repo, and like for everybody, again, it's all open. So we're like super happy if you guys explore it and let us know what it means. And if you like it, of course, if you like this, please share it. Add a star on GitHub, or whatever love you want to give us. We're super happy to to do this.
Very cool.
All right, fellas, this has been awesome, and I thank you so much, Mr. Jacopo. I'll see you in Italy, my man.
Is that?
Are you coming to Italy? Are you coming to Italy? I didn't know that.
I mean, if you're gonna be there, I'll come visit you. So
yeah, I will definitely come as well if we're doing a meetup in Italy.
I'm gonna do a
Let's do a meetup.
Cool. Let's do the spaghetti code. Spaghetti. Let's call it spaghetti code, and then we're good.
Let's do the spaghetti code meetup. I like it.
Yeah.
All right.
Yeah. One thing I want just to add is we're super happy to talk to people in the community. If there's any, if there's anything you think our experience can be helpful to. Again, we're not selling anything, so we're like super happy to sit down next to you and tell you what worked for us and what doesn't. We try to build in the open, so if you want to build something with us, or like testing something, please reach out. I'm very easy to reach on LinkedIn or on Google or on songs from Demetrius. You can find me very easily. And
maybe
on Slack.
Yeah.
He's on the
on Slack. Yeah, of course. Like super happy to chat and dig into some more if you guys find it useful.
Maybe we need an AMA, Demetrius, with Jacopo.
I think that is actually a really good idea. So we'll make it happen. Bye.
Okay.
Thanks for coming.
Guys, thanks again for having me. I hope it was useful.